She almost got experience arrested last time.
No,
Yeah,
we're not
so, it's not the greatest place to go right now.
Okay, so let's go ahead and do 9. This is from geometry, so don't, if anybody's writing that down, that's from geometry. If anybody's watching the video, that's from geometry, that assignment. So don't write that down, I just need to copy it down for myself. Okay, so special patterns. We've actually already talked about these. We call them special products, difference of squares, DOS, and perfect square trinomials. So we've already talked about those. But now we're going to do them when we do the factory, okay? So, you go 4, 8, 12, and 22. Got it. Okay, so let's look at, let's review. You did this on your test last chapter. This is special patterns. Patterns. Okay, so when we did this last chapter, we said multiply. Multiply? Oh boy, let's just go with multiply. We did something like this: x minus 7 times x plus 7. Most people were getting this. Some people on the test were not. So in this, we said multiply this together. We recognize this is going to actually end up being a difference of squares. What's our acronym for difference of squares? DOS. We call it a DOS. Okay. So we FOIL this together. We go x squared. And then our outwards and our innards, remember what happens to those? We'll show it, 7x minus 7x, but those are gone. And then minus 49. Some people are putting plus 49, but it's not. And then those cancel, and we're left with x squared minus 49, okay? So our goal today, though, is not to multiply these together. We've already worked on that. Our goal today is to recognize when we see this, when we see a difference of squares, x is getting squared, is 49 getting squared? Let me help you. No. 49 isn't getting squared. What's getting squared? 7. That this factors into this. Because we don't see it in the normal way of like what times what gives you 49 added together gives you, there's nothing there, right? So we just memorize, oh, this one would turn into this one. So if we look at this, and then our other one was when we had something like this, let's say y plus 6 quantity squared. On the test, some people were doing this. What's the error that people make?
You just say y squared plus 36.
Yeah, they say y squared plus 36. That's painful. Because it's like, no, I warned you. But you said, no, I don't want that warning. I disregard it. I want to do it wrong. Yes. Okay, congratulations, you won. You did it wrong. Okay, so, yeah, we got to do this. We got to FOIL it, right? So y times y is y squared. And then we go 6y and 6y would give you what in the middle? 12y. And then 6 and 6 would give you 36. So this, you actually don't have to memorize the special product here when you factor, because this one actually looks like when we've been factoring, right? And we would say, what times what? Hang in there, Nicole. Yeah. For all the other stuff. We've got probably 75 more years left, and that's all over.
Yeah. It might be reduced to 3 because I'm taking math class.
3 years? Wow. Your lifespan's gonna be that short.
Yeah.
Man.
Down to the, do it down to the second.
Planned. Yeah.
It's awesome. I didn't know I had that power. All right, so here, what times what gives you 36? Added together gives you 12. You would say, oh, 6 and 6, right? So you actually don't need to memorize this turning into this in order to go from this back to this. This one's a little bit more challenging. Okay, so let's do factoring now. Okay, so we call this number 1. Let's say I have, let's start with this, x squared minus 81. Now we look at this and we say, okay, for starters, do they have anything in common? I forgot to ask that question because I just look at no, nothing in common, right? So then I look and say, oh, it's not my trinomial, it's only a binomial. And then I look and say, oh, this is definitely looking like a DOS, because it's a difference of squares. What's getting squared here? X. What's getting squared here? 9. So we automatically memorize it goes like this, and then we say X, and we say X, and then we say 9, and we say 9. And then, does it matter plus than minus or minus than plus? It doesn't matter. So however you want to memorize it or write it, it does not matter. And we say X plus 9, X minus 9, and we're done. Okay? Now, if we had this, let's do this one. I don't know if you'll have any of these, but you might. We look and we are like in this mode of just memorizing and actually thinking. Don't do that. Memorize and think. And you say, wait a second, difference? No. This is a sum of squares. Do we have any special thing for sum of squares? No. And I'm not going to give you anything because there is nothing. So what would you write? If you can't factor it anymore, you write P rhyme. Yep, so just beware of that as you might see something like that. Okay. Now, number 3 here. Let's do x squared minus, pick a number like this, 80. Is 80 a perfect square? No. So what would we write? Prime. Now, there could be, you could maybe recognize that maybe if you go x and x, and then you could actually maybe go square root of 80 plus the square root of 80. Ooh. And that would be square root of 80 times square root of 80 is what? 80. So that one, but I don't think we're going to see any of these, so we would probably write prime, because we're thinking perfect square just being our 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, so on and so forth. Okay? So let's try another one. Here's a classic O, 121 z squared minus 1. What do we recognize about 121? It is 11 squared, right? And then, what about the 1? People kind of struggle with that one sometimes. 1. So this is a difference. This is a perfect square and a perfect square. And this is a perfect square because 1 times 1 gives you 1. Therefore, in the front here, some people make the error. They write 121z and then z like that. It's got to be the same thing here and the same thing here. Therefore, it is supposed to be 11z and 11z, and then minus 1 plus 1. Okay? All right. We're doing pretty good on them?
Yeah.
Let's try this. 49a squared minus 144. You guys do that one real quick. Okay, so we go here, we go here, we go here, we go here. Recognize perfect square, perfect square, perfect square. So what do we get here? 7a, 7a minus 12 plus 12. Okay, not too bad, right? Okay, this one says PST or not, right? PST, perfect square trinomial. Meaning, is it this that could turn back into something like that, right? That is a PST, perfect square trinomial. We call it a perfect square trinomial because this is a perfect square. It's something being squared, trinomial, because we have 3 terms written here. So if you look at this, would this fit into a perfect square trinomial? And actually, all they ask you to is recognize, and they say justify your answer. I'm not going to have you justify your answer. You're just going to look at this and then try to do the work and say, is it a perfect square trinomial? You could actually factor it and then identify if it's a perfect square trinomial, or just look at it and say it is. So, perfect square trinomial. Well, we can actually check and see if it's a perfect square trinomial by doing this. Is this being squared? Check. Is this being squared? Check. It is a trinomial. Check. However, is this x plus 49 times x plus 1? Because that's not a perfect square. That's something different times something different, right? So, and if we check that, we say, well, 1x and 49x gives me 50x. That's not what I want. So really what you're checking to see if it's a perfect square trinomial is, perfect square, 2 thumbs up, we got that. Is the middle term made up of whatever is getting squared here? So 7 times 7 gives you 7 plus 7, right? Which is 14, so the answer is yes. They say 14x is equal to 2 times 7x. I don't need the justification for now. Just is it a perfect square trinomial or not? Yes. And then what if I have a squared minus 4ab minus 4b squared? A little bit trickier. Is it a perfect square trinomial? A little trickier simply because we have the a squareds and the ab's and the b squareds, right? Double variable. But let's ask ourselves, is this a perfect square? A times a, yeah. Is this a perfect square? Is 4 a perfect square? Sure. 2 times 2 is b squared a perfect square? Sure. B times b. And then is this made up of 2a times 2b? Or I guess it would be 2ab and 2ab, giving you a total of 4ab. Well, it is actually. It kind of looks that way. Well, let's check this out. So you might say yes because it's made, if this is 2b and this is a, 2ab and 2ab would give you 4ab. But let's check this out. If we went to factor this, a times a, right? That's correct. And then you would say 2b times 2b, correct? Right? So a times a squared, 2b times 2b, 4b squared. But then we would have to say, to get a negative here, what would I have to do? A plus and a minus. And then if you do that, does that actually give you this term? No. And even if it doesn't give you that term, what you'd recognize is that then these two are not the exact same. So is this a perfect square? And this is not the same as this. No. So the answer actually is no. So this one is not a perfect square because this would actually need to be a plus right there. If it was a squared minus 4ab plus 4b squared, then it would be a minus 2b, a minus 2b. Then it would be, if that was the case. As in it would be a positive 4b squared, and then a negative 2ab and a negative 2ab giving you a negative 4ab. So a little bit of factoring and checking would help you on those problems. Then you're going to have something like this. And again, this just goes back to factoring. I think we just got a couple more here and then we'll be set. They're going to say, let's say this, a squared, whatever number this is, number 8, a squared minus 10ab plus 25b squared. Go ahead, factor that one. It's not some extreme problem. You've been factoring problems for the last couple days. This one's very similar to something like that. So go ahead and factor that one. And then we'll do another one here. And if you get to number 9, you can factor that one. Definitely looks a little more complicated with some big numbers in there. So, but it is factorable. Or a factor at some level. Check with your support team for number 8 and 9. Say, hey, what'd you get? pro tip on number 9, look for what they have in common, which they do have something in common. I know it looks a little messy. They don't have any variables in common, but they do have a coefficient part in common. If you're kind of stuck, pro tip, what number do they have in common? Anybody figure out what they have in common? 7. Factor out the 7. Then you can do one more factoring from there. And then I'll be with you momentarily. Okay, let's go over this together. Did you need to know any special product rule to be able to factor that one? You actually don't. One thing you could recognize is perfect square. Perfect square. This is 5 times 5, right? This is 5 plus 5, 10, except that it's a negative. So you could kind of recognize that whole pattern thing and just factor it immediately. But if you thought through it, what times what gives you a squared, a and a, what times what gives you 25? B squared, right? So 5b and 5b. If this is negative, this is positive, it's going to be a negative and a negative. That's good enough. If you wanted to go a minus 5b quantity squared, that's fine too, okay? So either one of these would be acceptable to put for your answer, okay? Here we recognize that a 7 in common. We pulled the 7 out. We ended up with 9x to the 6 minus 25y to the 10th. Then we looked and we said, oh, 9, perfect square, 25, perfect square. What about the x to the 6th? What times what gives you x to the 6th? X cubed, x to the 3rd. What times what gives you y to the 10th? Y to the 5th. So are both of these perfect squares? You bet. So could you break this down into this times this? Absolutely. So 3x, not 3x, but 3x cubed times 3x cubed. Remember, when you multiply the same bases, what do you do with the exponents? Add them. So if you're wondering if it's a perfect square, if it's even, it will be a perfect square. If it's odd, it won't be. So even, and then you just divide by 2 to figure it out. Minus 5y to the 5th plus 5y to the 5th. Can you go any more? No, can't do any more. Okay? So your homework, if you start on this. This would be due Friday, right? Page 438.
How's it going there? Yes.
This is 9.401 through 35 Bob 2. And a handful of other ones for you. 2, 10, 14, 24, 30, 42, and 50. Okay, there's 9.4 homework. What is due tomorrow, guys?
9.3.
9.3.